Hey everyone, Jay here, and today's video I'm going to go over some examples of loops, a few different ways of controlling those loops in Python. All right, so let's get started. Uh, for this particular one, I am importing random, and you'll see that in a moment here. I'm using random as a kind of fake processing area because I don't have a whole bunch of code to actually put into a loop. So I'm just using random to kind of emulate that. Let's skip ahead into my main function where I have four loops. I have two while loops and two for loops. That is pretty much all you need. You need with loops. You need a while loop and a for loop. There is such a thing in programming called a do while loop. Those are not required, like ever, because you can use a regular while loop and just do it once beforehand, and you'll have a do while loop. Yeah, you're duplicating code. You could put it all in a function if you wanted to, but in essence, you don't need the do while loop because you can create that with the while loop. So let's look at what the while loop is, what it does, and two different ways of controlling it. So oftentimes we're programming something, we're going to need to repeatedly do something over and over and over again. Maybe we're just prompting the user for input and we're letting them do their thing over and over again. Maybe it could be as simple as that. Or maybe we're iterating through some complicated math function. We're doing something over and over again, or really anything. Computers are always doing things over and over and over again. That's what computers are good at. They are good at doing something over and over really quickly, much faster than humans. They're great at calculating things is doing things over and over again. Technically, the way computers do multiplication is they just add a lot of times and they do it fast. Right? So like 10 times 52 is really just adding 52 times, right? That's how computers are doing it actually. And that's why humans could do it, except, we figured out a shortcut, but we can't program computers to do that shortcut real well. So we have the while loop. You got to control the while loop. The way it works is while this statement continues to evaluate as true, every time the loop is going to test that statement, see if it's true. If it's true, it's going to do whatever is in the body of the loop. And then it's going to keep doing that until this statement stops being true. Now, the last time it runs and it stops being true, it won't execute the body of the loop that last time. As soon as it becomes false, it won't execute that one more time. Okay, so you can trust that that's not going to happen. That would be super bad if it did happen. We would have to like rewrite every program on the planet because everything would happen one more time, and there would be no way to go backwards and undo that action. So it doesn't do that. All right, as soon as it becomes false, it will not execute the body of the loop one more time. And so this is the loop statement here. We have while, we have our statement, which is basically an if statement. It's really no different. While, if this is true, you could pretend it says that. We have our colon here, and then, of course, we tab over. Everything in here is the body of the loop. So this first loop is looping with a counter. We've been talking about loops and counters for a little while. If you've been watching all my videos, you need to prime the counter with some value. So I'm just kind of emulating that I'm handing out 6 cookies among some people. So I'm setting my cookie equal to 6, and while my cookies are greater than 0, as long as I have more than 0 cookies, I'm going to pass out 1 cookie at a time. I'm going to say cookie minus equals 1, and then I'm going to print cookie. So I'm just creating a real quick while loop that emulates handing out some cookies amongst friends. Maybe not friends, but once you get a cookie, we're friends. So that's all that does. As soon as it stops being true, it's going to stop executing. Something super important with while loops, all while loops, whether it's the counter or the next one that we're going to look at, you have to put in the body of the loop, you have to put some way of changing this statement to be false. Okay, it's true when it starts, or it's true when it starts. You have to put some way in the body of the loop to make it become false. If you forget that, and it's a very common accident to happen, you're going to create what's called an infinite loop, where this statement is never going to be false, and the loop is going to just continue forever, and you're going to have to manually shut down the program because it's going to hang up, it's going to be frozen, could even freeze the entire computer. Depending on what's happening inside the loop, you could fill up the whole RAM of the computer and really slow things down, maybe have to shut down the whole computer. But yeah, so don't do that. It's a very, very common mistake because we get caught up. Oftentimes, we're writing our code, we get caught up in what we're doing, and we forget that the while loop has this process that it has to follow. And we're just thinking about solving our problem. We're not always thinking about the loop itself. So don't forget that. Okay. And I kind of mentioned this value is going to be true the first time. Well, I could set this to, I could set this to -6 and we'll go into the loop and it would be false immediately, and the loop would test that first time. You'd run the test, but it would fail the test. It would come out false, and it would never execute the body of the loop, not even one time. That's totally a plausible thing to do. There are many times where a program will do that. It will say, hey, we're going to test this value, and we're going to do it however many times it needs to be done, and that could be 0 times. Okay, so that's a totally legitimate thing to do when it's needed, when it's called for. Okay, so that's a loop with a counter. Moving on to my next loop, I have a loop with a Boolean trigger. Now, I like these for like the overall process of simple programs. Like if we're going to prompt the user for some input and we're going to do something every time on the very outer loop, I like to do a Boolean trigger, and I have a while not game over. That's very common for me. I think, oh, while it's not game over, my program is running. So I use that value a lot. So I will initially set my game over to false, and I'll say while not game over. You're programming this, you might program it to be a different named value, and it might be while that thing is true, I'm testing while it's not false. Okay, not false is also the same as true. Either way, same thing. Once the loop gets in here, now instead of doing a counter, where the previous one I was counting down, okay, you can count up, you can count down, doesn't matter. This one I don't have a counter. I'm just going to test, I'm going to do some kind of function, and I'm kind of faking a complex process. I'm saying my algorithm is a random number between 1 and 9. And then I'm testing if the algorithm becomes equal to 5 at any point, game over equals true. So this fake little algorithm thing I have here is just a placeholder for any complex process that you can put in here. And then you can test the outcome of that process, and whatever outcome you choose, whatever outcome is the end outcome, you'll set that to trigger the loop to stop. Okay, it could be anything. I'm just using a random number, but it could be, again, if we're using the user input thing, you could say if the user inputs 0 or X, we're going to get out of the loop and do something else. Could be anything. So any process you want to put in here, and then it's going to somehow return a value or set a value in some way, test that value, and based on its value, you're going to either continue the loop or not continue. Right? And it does not have to count up, down, left, right, or anything. It can just be like I have right here, purely random, pseudo-random anyway. Could just be random numbers. So when I run this at the end, we're going to get some random number of game not over prints. Theoretically, it's possible that it runs forever and the number 5 just never pops up. Right? And that's not going to happen, but if it does, I'll let it record a while. So that's the while loop again. Both of these loops are the same loop, right? Just one, we're counting, so we're getting a very predicted number of executions. We have a starting count number, and we'll execute until that number reaches a threshold. In this case, it starts at 6, and my threshold is set to 0. The second one, instead of by counting or iteration for the threshold, I have one specific threshold. My algorithm has to be equal to 5, and then my process could be any number within any kind of theoretical range. My algorithm could be more than just 1 through 9. It could return anything, right? It could return strings of characters. It could return an array of things. Who knows? Could be anything. I'm testing for a very specific value that is the exit value for my program. All right, moving on to the for loop. Let's see, got all this on my screen? Okay, the for loop is very useful, and what it does is it iterates through a collection of elements, a collection of items, okay, and it will loop once for each of them. That's why it's called the for loop. In programming, oftentimes you'll see the for loop given a start point and an end point, and it will be used in place of this while loop with a counter. Okay. For many programmers, the for loop is just simpler for them to write and understand that it's going to loop the X number of times every time. So the for loop and the while loop with a counter are fairly interchangeable. It depends on what your starting values are that you have available to you, but you could use them in place of each other in many instances. Okay, so in Python, the way the for loop is created, we have for x. This is just a counter variable x for x in a range from 0 to 10, and I'm stepping 2. So I'm really using this range function right here. The range function, the built-in function in Python, you give it a starting point, a stopping point, and maybe you give it a step. So I'm going to start at 0, go to 10, and count by 2s. Okay. So for all the x's in that range, I'm going to print x equals whatever the value of x is. And that's what this loop is going to do. Traditionally, it would probably not be counting by 2s, it would be counting by 1s, and the range would be from 0 to the length of an array or the length of a list or something, right? So it might be for I in range 0 list.len. If I remember my list Python syntax correctly, I believe it's .len. That may be inaccurate, but you get the idea. It'd be from 0 to the length of a list that you're working with. Okay, and it would be traditionally I is used for the iterator, so I can switch that I instead of X. A lot of Python examples, you'll see them use X. That's Pythonic code, but traditionally programming we use I for the iterator value. Okay. So Python has a little bit different syntax in the for loop than a lot of other languages, but it does the same job. Okay. Next, in my last for loop, this one is a little bit more like a for each loop, which I'm quite familiar with. I'm primarily a PHP developer, a lot grown, I know. PHP has a for each loop, which is a for loop, but it will loop through each element in an array. In this case, we have a list in Python. And for you create this name items, that value can be anything. That's just a name variable that you're creating for the loop. I like to use items for items in this list. It's going to print the item. So when this loops, once for each one of these items, it's going to print chips, then print cake, then print tacos, then print coffee, then print ice cream. Okay. Yes, some of my favorite foods, apparently. So that's what the for each loop is going to do. It's pretty much exactly the same as the other for loop, which is, to Python's credit, something nice that they made two, what would be two different loops in another language is the same loop in this language. So to Python's credit, they did make some changes on that when the language was first developed. So I like that. But those are these two loops, the while loop and the for loop, and then two variations on controlling them in each one. So I'm going to go ahead and run this and then show you the output. All right, there's the output. We have 1, 2, 3, 4, 5, 6 cookies. Randomly, only one game not over. Our for loop iterator counting by twos, 0, 2, 4, 6, 8. It did not execute on 10 on that last one. Okay. It did execute on the first one. It did not execute on the last one. So note that the for loop with a range, it is not inclusive on that final number. Okay. And then the for each loop, or the for loop on a list, output each item in the list. Okay, I'll be making this code available in our class online if you want to take a deeper look at it. But otherwise, it's fairly simple, and you can see all of it on your screen right here. That's it for an example on loops in Python. Thanks for watching, and I'll see you next time.